I have cleverly hidden part of the physical setup of this network from you because I know you'll skip ahead to that and you won't listen to what I have to say for the next minute or so about the weight attribute. But if you go ahead and start writing that out now, I understand because frankly there's not too much hidden from you. A couple of quick facts about the weight attribute. Got to remember this. Cisco proprietary, locally significant only, and we mean locally significant to the router itself, not to an AS, because the weight attribute is never going to be advertised to any other router, whether that be an internal or external peer. Now, the path with the larger weight is preferred. Sounds good to me. The default for this attribute is a bit odd, says the author. Sounds more like an opinion to me, but it is a little odd. The default weight for a route that's originated on the local router is 32,768. For all other routes, it is 0. I kid you not. We're going to see this live in just a moment. And we're going to work with the weight attribute and see if we have any other issues, because you know you always want to spot the issue as you're going along, which may be why I'm showing you these diagrams as well. Here's the physical setup for this particular lab. Routers 1, 2, and 3, we're back to the frame segment 172.12.123.0 with router 1 as the hub. And routers 2, 3, and 4 are also on the same Ethernet segment 172.12.234.0/24, and as always the router number is the last octet. Now here's the BGP configuration, so if you haven't finished drawing this one out yet, you just pause the video, but you knew that. And here are the ASs. Here's our BGP deployment, and you can see routers 1, 2, and 3 are in the so cleverly named AS123, but that is a good tool to get in the habit of doing. You can see that router 1 has a couple of internal peerings, one with router 2, one with router 3. Routers 2 and 3 do not have a peering, so we don't have a full mesh there. But routers 2 and 3 do have an external peering to router 4, which is sitting over there all by itself in AS4. I'll also tell you right now that I have added a loopback to router 4, 4444/32, and I've already advertised that into BGP with the network command because you know how to do that. So you see any possible issues we might have before we get to the weight attribute? Let's go ahead and bring the live equipment up and have a look around. We've got router 1 ready to go. Let's start on 4 because I want to show you that I was not lying to you about that weight attribute. Show IP BGP. Here's that network 4444. It's locally originated, so we see a next hop of all zeros, and we see a weight of 32,768. So all is well here. Now let's go to the next hops as far as the peerings are concerned, which would be routers 2 and 3. And I just wanted to verify those peerings with you as well. And here they are. There's dot 2 and there's dot 3, and they've been up at this point for about half an hour. So let's do a show IP BGP here. And we see a valid and best route to that loopback. And the next hop is 234.4, exactly what we would expect. And also note that the weight is at 0. We hop over to router 3. And there's your network, and there's your next hop. We've got valid and best, and a weight of 0. So far, so good. And everything I've said has been borne out here in the lab. Let's go up to router 1 and see what we can see. And everything's fantastic because we have 2 entries. You know, we like redundancy. The next hop for each is 234.4. We know why, because of the next hop rules we saw in another video. And the weight for each one is at 0, which backs up the weight attribute theory that I gave you earlier. And you're saying right now, but there is no best route. And you are correct. It would be so easy to look at this, and some people would, and say, well, everything's fine here because you've got that asterisk there and you've got 2 valid routes, but we need valid and best. Now, let me give you a little pop quiz. What could you do to remedy this if I told you, or Cisco told you, that you could not configure router 1 to resolve this issue? I think you know what the issue is. Matter of fact, I'm positive. But we're going to see exactly what the issue is in about 15 seconds here. But what would you do if the exam or the proctor or me told you, you can't configure router 1 to solve this issue. You have to configure another router or routers. Well, first off, let's absolutely verify what the issue is. And the first thing I would do, in any case, if I knew it by looking at it or not, I would just run show IPBGP followed by that network number. And we see that nasty word inaccessible again because of the next hop. That's the problem. We've seen that in previous videos. We're seeing it here. Router 1 has no idea by default where 234.4 is because, again, you can never assume that we're running in a routing protocol. You can never assume that we're running OSPF or EIGRP or RIP to let Router 1 know where 234.4 is. So Router 1 has no idea. It gets these next hops of 234.4 from Router 2 and Router 3. Says, you know, what do you want from my life? I don't even know where that is. So we could put a static route or a couple of static routes on Router 1 to fix the problem. But as I said a moment ago, what if we were told we couldn't? What if we were told we could only use BGP commands to make this happen? And I know what you're doing. You're sitting there saying, all right, I know what it is. It's next hop self. And you're absolutely right. So 12.123.1, next hop self. If you really hate to type, you could just copy and paste that. And we see one of them is changed. Let's do a clear BGP soft in. And there we go. So both next hops have changed. And notice that for a moment there in the first output, let me highlight that. I love when stuff like that happens. And I mean that, I do. Because right here you could see that the next hop information from Router 3 had updated, but not from Router 2. So that's why I went ahead and did a clear, a soft clear, so I didn't lose my adjacencies, but I went ahead and forced an update with both routers. So when we were getting that information of the next hop of 123.3 and 234.4, naturally valid and best was going to be this one for 123.3 as the next hop, because there's no way in the world it could be 234.4. We already know that. But once I did the clear and updated it with router 2 and 3, notice that the valid and best is now 123.2. And what do you think the reason for that is? And that great big path, almost a great big pile of best path selection process, but that's probably not the best way to put it. But I said it anyway. So we went all the way down to the red, you know, with this one, because every value is the same and they're all internal and they're all valid and they all have a local pref of 100, etc. The origin's the same, so it went all the way down to the red. So far so good, but what if we now finally want to use the weight attribute in order to change the path selection here? And let's say we wanted to assign a weight of 200 to paths coming in from 123.3. This command's a little different in that you're still going to use the neighbor command, but you need to use it on the router that is actually going to have the routes with the changed weights, because remember, weight is locally significant only. If we go over to router 3 and start changing weights, it's not going to do anything here on router 1. We got to do it here on router 1. And we're going to take the all or nothing approach and do a router BGP 123. Router BGP 123, thank you. Neighbor 172.12.123.3. And what do you want to change? We got so much stuff we can change. It's more than one screen. It's all the way at the bottom. Weight is the one we want here. This, of course, would be a great solution if you were taking an exam, NP, IE, whatever, and just said, you know, you need to change the path selection here, but you're only allowed to configure router 1. Because we know that's locally significant only. Boom, we just do it on router 1 with the weight command. And we put weight there, and that's going to be the default weight for all routes from that neighbor. And those are all the options. Let's do a soft in there. And you can see the path selection has changed. The valid and best path is now the one with the next hop of 123.3. And you also see weight of 200 versus 0. And this is the very first attribute that's even considered. So that's the end of the process right there. And let's run show IP BGP 4444 just to verify, etc. And you can see now the weight of 200. It doesn't even mention the weight of this path. I guess it's assuming that, hey, you already looked at show IP BGP and saw it. But the only time you'll see weight here apparently is when you actually change it. Otherwise, you know it's at the default. We are going to see a little more lab work with the wait command before we move on to summarization. And we'll do that on the very next vid. See you there.